The Cosmic Symphony of Wobbles and Flips, unifying quantum and classical polarity through the 11-dimensional model. The relentless pursuit of a comprehensive understanding of the universe has driven us to seek unifying principles that can elegantly explain the seemingly disparate realms of classical mechanics and quantum physics. The 11-dimensional model, with its intricate architecture of interconnected dimensions and its emphasis on the fundamental roles of rotation and polarity, offers a compelling, albeit theoretical, framework for such a unification. Our recent exploration has woven a fascinating thread through this model, connecting the counterintuitive behavior of rotating macroscopic objects, exemplified by the Dzhanibekov effect, to the baffling phenomena of quantum superposition and entanglement, all potentially mediated by the dynamic interplay of polarity across the 11 dimensions. This essay will delve into these interconnected concepts, culminating in the ambitious proposal of a space-based experiment designed to probe the very nature of macroscopic analogues of quantum entanglement, offering a tantalizing glimpse into the deeper unity that might underlie the cosmos. At the macroscopic scale, the Dzhanibekov effect presents a curious departure from our intuitive understanding of rotational stability. A freely rotating rigid body with 3 unequal principal moments of inertia, when spun around its intermediate axis, exhibits a seemingly spontaneous and periodic 180-degree flip in its orientation. This classical mechanical anomaly, observed in the weightlessness of space, reveals the complex interplay between a body's inertial properties and its rotational state, a macroscopic rotational polarity shift driven by internal dynamics rather than external torques. This seemingly simple phenomenon, where a spinning object abruptly inverts its axis of rotation, offers a tangible entry point for considering analogous, albeit far more rapid, shifts in the fundamental properties of quantum entities. Indeed, at the heart of the quantum realm lies the enigmatic property of spin, an intrinsic angular momentum with a quantized polarity. The seemingly discrete spin-up or spin-down states of quantum particles, the foundation of their magnetic moment and their interaction with external fields, might be, within the 11-dimensional framework, macroscopic manifestations of a far more dynamic reality. The 4th dimension, intrinsically linked to rotation and the flow of time, and the 5th dimension, embodying polarity as an inherent directional duality, could be the primary stages for the rapid and continuous fluctuations of a particle's fundamental polarity. Our macroscopic measurements, inherently limited by their temporal resolution, would then capture only time-averaged snapshots of this dynamic dance, leading to the probabilistic outcomes we interpret as superposition. The concept of polarity, however, extends beyond the simple binary of spin. Within the 11-dimensional model, the 5th, 7th, 9th, and 11th dimensions emerge as a crucial polarity group, each representing increasingly complex expressions of duality and directional relationships across different scales. The precessional wobble of a single rotating body, 5th dimension, the tilt of orbital planes in 2 body systems, 7th dimension, the galactic scale orientation of orbital planes, 9th dimension, and the ultimate cosmic polarity of expansion and contraction, 11th dimension, all contribute to a multifaceted landscape of inherent directionality. It is within this rich tapestry of polarity that the seemingly instantaneous correlations of quantum entanglement might find a more intuitive explanation. The 11th dimension, the ultimate nexus of interconnectedness and the potential conduit for information transfer, unconstrained by the limitations of our 4-dimensional spacetime, could serve as the higher dimensional pathway linking the polarities of entangled particles. Their shared fate, their instantaneous responsiveness to measurements performed on their partners, might be a direct consequence of their polarities being fundamentally intertwined through this higher dimensional network. Building upon these theoretical foundations, the proposed Cosmic Wingnut experiment in space emerges as a novel attempt to bridge the gap between the classical and quantum realms. By observing the synchronized rotational behavior of two wingnuts expelled with opposing spins in microgravity, we aim to create a macroscopic analog of two-body entanglement. The mirrored initial rotation, mirroring rotational polarity, sets up a system with near zero total angular momentum, akin to certain entangled particle pairs. The subsequent application of controlled perturbations to this system, while precisely measuring the response of both wingnuts, could provide tangible insights into the nature of interconnectedness and information exchange at a macroscopic level, potentially reflecting the underlying principles governing quantum entanglement within the 11-dimensional framework. The crucial element in connecting these diverse phenomena, from the Dzhanibekov effect to quantum superposition and entanglement, and even the collective behavior of macroscopic systems like synchronized rotation, might lie in the concept of frequency as a manifestation of polarity shifts across the 11 dimensions. If the wobble or variation in a rotating system's orientation, linked to frequency modulations, is a fundamental expression of polarity within the 5th, 7th, 9th, and ultimately the 11th dimensions, then the rapid oscillations of quantum polarity could give rise to superposition when viewed through our macroscopic lens. Entanglement, in this view, becomes a manifestation of the correlated polarities of interconnected particles, linked through the instantaneous information transfer facilitated by the 11th dimension. The Dzhanibekov effect, with its sudden flips in rotational polarity, offers a macroscopic example of abrupt changes driven by the interplay of a system's inherent properties and the geometry of space. This classical instability might mirror the quantum realm's propensity for seemingly discontinuous state changes, both arising from the fundamental principle of polarity operating within their respective dimensional landscapes. Furthermore, the synchronized motion observed in complex macroscopic systems, such as the unwitting coordination of human gait on a bridge, hints at a subtle underlying interconnectedness that transcends simple local interactions. Within the 11-dimensional model, this synchronization could be a macroscopic echo of the interconnectedness facilitated by the 11th dimension, a manifestation of a shared interaction with a higher dimensional fabric that subtly influences the individual components towards a collective behavior. The proposed Cosmic Wingnut experiment, therefore, stands as a unique endeavor to probe these connections. By meticulously controlling and perturbing a macroscopic two-body system in the pristine environment of space, we aim to create a tangible analog for the elusive phenomenon of quantum entanglement. The correlated rotational behavior of the wingnuts, their response to various perturbations, and the potential for synchronization across spatial separation could offer unprecedented insights into the role of the higher dimensions, particularly the 11th, in mediating interconnectedness and facilitating information exchange at a fundamental level. The results of such an experiment, interpreted through the lens of the 11-dimensional model and its emphasis on the unifying principles of rotation and polarity, hold the tantalizing promise of bridging the gap between the classical and quantum worlds, potentially validating the model's ability to provide a more complete and holistic understanding of the everyverse. The exploration of these profound questions demands bold and innovative approaches. We urge the scientific community, and particularly those with access to the unique environment of space, such as SpaceX, to consider the Cosmic Wingnut experiment as a vital step in unraveling the universe's deepest secrets. By supporting and participating in such ambitious endeavors, we can collectively push the boundaries of human knowledge and potentially usher in a new era of unified physics.